Thanks everyone for showing up. I'm not too sure how familiar or who's in the crowd right now, but could we see with a show of hands who is familiar with blockchain just in a general sense? Raise your hand. Maybe some Bitcoin owners. Yeah, Ethereum. Cool. So this is, I think, the only blockchain Airflow combination. This is actually one of my first technical summits that I've been to. I've just only been at like Bitcoin summits and everything. It's a much different crowd, I can tell you that. So just a bit about myself. I'm a staff engineer at Circle. We're running the data platform team. You can follow me at Nate Rose 2 on X. But previously, I was working at Microsoft. I was working with the Databricks team within Azure and onboarding that into the platform, and then also at Ripple, where we were actually using Cloud Composer. So Airflow the past 4 years and working with it pretty extensively. So this agenda, I just want to make sure that we're level setting. We are going to talk a little bit about blockchain because not everyone in the crowd is familiar with how this is a huge database solution or database problem that we're trying to ingest from these protocols. Then we'll talk about our data platform problems as we're a relatively new team. We've grown within the past 2 years from 20 to about 60 to 70. And then we're going to talk about automating CICD. So there is multiple talks that look into using continuous integration, continuous deployment for Airflow. I think Yarrick is going to be tomorrow, so definitely check that one out. This is based off of some of the learnings that he's also provided, but this is in practicality, implementing it in a business use case. Then we'll finish off with like just managing variables, configs, and some learnings that we also did, as well as onboarding to Astronomer. So just what is Circle? By the end of this, maybe everyone could get endorsed by me on LinkedIn as Bitcoin or crypto experts. But we are interested in the dollar because of its stable value, right? We can provide confidence in the dollar because of its international capabilities, its backing, and it's highly regulated by a federal entity. But then we also want the flexibility of the blockchain because it's 24/7, it's near instant settlement. For foreign entities, they want to be able to use the internet and use the speed of the internet for monitoring transactions and being able to receive payments through the transactions. And that's where we introduced the USDC. This is actually minted by Circle. USDC is a backed digital stable coin that is closely pegged to the Federal Reserve or to the US dollar. And how it works is that we convert US dollars. We see the Federal Reserve and convert it into a digital equivalent as what we call USDC, US dollar coin. And entities and institutions leverage that to be able to use decentralized finance for being able to send payments at the speed of the internet. So what Circle does, outside of just solely minting USDC, we also do programmable wallets. So if you have a wallet, we can actually embed coding so that you can automate some systems when it comes to USDC. We have smart contracts, which is just an extended version of programmable wallets. And then we also have cross-chain transfer protocols. I'll talk about like the cross-chain ingestion schemes that we currently do because we ingest a ton of data on a daily, monthly, yearly basis. We also are the providers of the Eurocoin, but that's a little less popular. At the moment right now, in volume, we have about $35.2 billion of USDC in volume, just to show you like the sheer size of who's leveraging it and some of the transactions we'll talk about and the data platform, data ingestion insights that we're able to generate from this. But we're looking at the volume of 35.2 billion USDC in circulation, but it's also on different protocols, different chains, right? So we're looking at Ethereum, Base, Solana, and we have to ingest a lot of this data into our insights for auditing purposes, for compliance purposes, to build strategy and for business insights as well. So this is an example of something that we look at quite extensively. This is actually a transaction on a blockchain, right? So you have your hash, encrypted hash. We take that hash, we could look at the transactions. A block has multiple transactions embedded into it, and then we're able to index based off of the size of the block. So think of it as like a shard, and each block is a shard that we're able to index across it. So when you do the calculations, this is what we're currently doing. This is actually a live feed of what we're ingesting from Arbitrum to Polygon to Avalanche. These are just different chains, and chains can be layer 1, they could be layer 2, they could be abstractions. Think of it almost similar. If you're not familiar with blockchain as like assembly code versus an IDE or programmable code, this is how blockchains are being introduced and being built around. So per minute, we're ingesting 1.42 gigabytes approximately. Per day, about 2 terabytes, and then per month, 61 terabytes that we're ingesting off of these chains at any given moment. So how do you handle that, right? This is a look at our dashboard as well. So we're using Airflow to manage our data platform, our data orchestration framework and engine that we provide, not only for the Transform ETL movement to the data warehouses, but we also use data warehouses like Snowflake and BigQuery for our data scientists to leverage so that they can provide the insights and generate that. We use Superset for our dashboard solution that we're able to also layer on top of it open lineage so we can see the movement of data from database all the way down to a dashboard that might be visible to like our CEO. This top left is actually showing the volume week over week of what the transactions amount that was spent versus what was received. And we look at that to see and understand the activity of USDC on the multiple different chains. Our DAG bag size is 591, so that's actually surprisingly small, or maybe it's big for certain shops, but our task running can range all the way from like 150,000 per hour to 200,000 tasks at any given moment. So we started to see a ton of problems because we were scaling up really rapidly. We started off as an MWAA shop, so we don't want to get into the business of really contributing to Airflow. We are blockchain developers, we're blockchain data analysts, so we want to really have a reliable solution or managed solution for data orchestration that we can rely on that's resilient. And we wanted to also introduce, as we started to onboard new data scientists, new data engineers into the data team, we saw that there needed to be a centralized place for us to do approvals, to do code pipelines, enforcements. We wanted to improve a way of handling persistent configurations around our environment. And then we started seeing a specific problem, and I'll get back to this. It was our web server. We kept getting 500 errors, bad gateways, and we wanted to reduce the amount of outages that was occurring within our solution, because for a developer, if they're not able to get to their Airflow console, then they're not able to run backfills or DAGs directly for development purposes. So just repeating the objective, we want to centralize the process of deployment. We want to potentially introduce a static testing framework to enable quality assurance, smoke testing, integration testing, and then we want to automate the continuous deployment of like Airflow configs, our various variables, as well as our connections and source code that our DAGs depend on. So this is an architectural proposal that we started off with, and I'll go into each 3 of the different parts separately. But this is just our first attempt of, taking a huge issue and providing like one meal. Yarrick tomorrow is going to provide you a 5-course meal. We're going to just do lunch right here, okay? So we wanted to start off with actually containerizing our entire Airflow environment, which was depending on Python packages. We had our own custom code library, which was pushed into Code Artifact, AWS Code Artifact. So we wanted this pipeline to actually be triggered based off of any modifications to the requirements.txt. We wanted to install all the Python dependencies into a Docker image, and then we can actually have a lot more mobility when it comes to this image by being able to run it locally, being able to run it inside a GitHub Actions runner, and also being able to run it on our cloud console inside MWAA. We also wanted to version this with the pull request tag and hash, and this is solely for development purposes. Actually, so with MWAA, it's limited to Celery executor, so you can't actually push a Docker image to run on the MWAA. This is due to the Kubernetes executor limitations of it, but I'll get to that. The next part is actually just running our CICD against our DAG code. So we wanted to trigger on changes to our source DAG directory. We want to check for linting, just do some pre-commit stuff that's general software engineering best practices that we wanted to enforce onto our data engineers. Verified variables are available in all stages, so dev versus stage versus prod. Do some Q&A testing, and then also deploy the code to an S3 bucket in MWAA. So just a double click into the quality assurance test. This is really simple, straightforward. You're just grabbing the DAG bag and you're looking at, DAG owners. Are they being set? What's the duration for parsing the DAG? This is actually looking into the quality of the code, of the Python code. And then also DAG ID. This is actually turns out to be a really good use case because when you have multiple DAGs with the same file name, that's actually competition. It's a little bit of a deadlock that you start to see inside Airflow. And this is what it looks like. We have 4 different environments. I don't know why we have this. I came to the company and we had this. It's like taking software engineering, like app development and trying to use it for data applications, but it's cool. So we have 4 different environments and we have to promote it through gated approvals just for compliance purposes, risk purposes, and then also just best practices. So devs are adding their DAGs into a shared dev environment in S3. They don't have access to these data connections and these data platforms locally, so they need to add it to a shared dev environment. But what that leads to is that if I want to change or introduce a Airflow operator, I may have to change the requirements.txt, and that could take down the entire environment because it's a shared environment. We also have gated approvals. Just for our GitHub Actions purposes, on merge, we just promote up to our staging and pre-prod environments. And then we also have a startup script that adds the Airflow configurations that we're directly coupling to the code so that we can see any changes that are incoming and have elevated approvals for those sort of PRs. And this is the final pipeline. So this is actually our test suite. So this gets triggered when some of our custom curated circle operators are modified. So we wanted to make sure that there is, I think between 6 operators that amounts for about 70% of our DAGs that are dependent on it. So we want to make sure that any changes to those sort of operators are fully vetted and confirmed that they are able to run successfully. So this pulls the Airflow developer image down so that we can actually do some sort of test suite changes, invoke our test suite. So this includes smoke tests. We are also able to do some lineage tests using a tool called Data Hub, additional logic on importing, and then run our unit tests against our base operators. There's 2 types of tests. I'll talk about this quick one, which is our unit test. This is basically a lot of mocking that we can do with some of the data sources. We can also check for import errors because now we have access to the Airflow CLI because of our developer image. And then we can also completely run our RDS. So this is our databases that are holding our blockchain data directly there and run our tests inside our GitHub Actions to confirm that they are able to run validly. I'll actually skip this one about environmental variables. This is pretty straightforward, but this is basically where to place your environment variables. This actually changes when we start to go from different managed Airflow environments from, say, MWAA to like an astronomer to like a cloud composer. But based off of your managed solution, it could change where you place your variables. So for example, if your variables are being added directly to the Airflow console, that's the Airflow API that you can maintain them. But for more abstracted managed solutions, you can actually have a elevated environment manager so that those variables are available to multiple developer environments, which is what we're pursuing. This one's really interesting. So we built a data quality framework. So this actually creates the temp table for specific queries. So we run a DQ check on some of these temporary tables, and some of the checks look like, duplicate checks, accepted value, and aggregated ag values as well. So if the check passes, we'll merge the table, and then we'll have like a TTL of like 7 days. And if the check fails, then we give the reason and we throw it back to the developer, and they could modify it inside their code in real time, right? So we want to prevent the amount of time for them to confirm that their pipeline is valid, so that when they run it inside their developer environments, we don't have to see just bad crap code and queries. So let's go back to it. The 500 errors that we were receiving, right? So this is the bad gateway. We started scaling our data environment, our orchestration framework, and then we started seeing that this was really taking down our entire web server. So the immediate answer is, do we scale up? And if you have unlimited bank account, that's great. Oh wait, we meant USDC, so technically we might have unlimited bank account. I'm joking. But we could look into other solutions, right? So we looked into increasing the connection pool size. We looked into scheduling after task execution. So this is a config that looks into confirming that once the pipeline actually runs, your DAG runs, that it has a latency before it's able to run again. We could stagger DAG so that we can create a threshold of when these DAGs can run instead of having some peak hours. But we went through all these different scenarios, and it came down to source code was pointing at CloudWatch was writing to logs and ingesting the log environment in a pretty bad way, so that we had to just upgrade our environment. So upgrading to a later stable version, we were on 2.6 or 2.4 at the time, and we upgraded to Airflow 2.6. And that was one of the reasons why we wanted to have a little bit more hands-on approach to how we look at Airflow in a managed environment. So we started investigating alternatives. This last one here is just looking at lineage using Data Hub. So Open Lineage is powering a lot of different tools. I believe it's going to be empowering some native tools for Airflow as well in the future. So we're able to notify downstream dependencies for pipeline failures. We can enforce lineage checks at our GitHub actions level. We could capture node graphs and see the movement of data from database all the way down to dashboard. And we also have better discoverability with tools like Data Hub, because if we just want to find all the charts that are correlated with Solana chain, we can be able to find that and start tagging and labeling using those different schemes. Looks like I'm less than 5 minutes here, so I'll just kind of run through. So now we're exploring Astronomer for a managed Airflow solution. This introduces the Kubernetes executor. So now we can actually take that image that we have and run it inside our Airflow environment. We can also look into ephemeral Airflow environments. So we had that instance where everyone was sharing that dev MWAA Airflow environment, and now we're able to have curated ephemeral environments for Airflow that can be coupled with pull requests for our data engineers. And after 24 hours, they could be pulled down. We also have the opportunity to use local Airflow development just a little bit more extensively. That's coupled with our Astro Cloud. So one thing that we did not have the full capabilities of doing was with our local Docker image, we didn't have our connections, right? There was only certain connections that we could directly access. Now there's a seamless way of pulling that down using our Astro kind of integration with that. And this starts to reduce our reduce our environments, because now we don't need necessarily a shared staging or pre-environment. We could kind of reduce it down to 2 environments where we have a direct dependency on local Airflow development to confirm that DAG iterations can be run and executed on your local device. And then for shared environments, dev deployment, you can go ahead and confirm that this is more like a staging environment in just a general sense. Looks like time is up. This is more about the developer flow, the flow cycle of how that looks like in practice. And if you're looking for more resources, I suggest checking out Yarek's talk or hitting the Data Pipelines Bass's textbook. That's it for me. Thanks.